I just want to note, I'm not just a naturally very sweaty person. The AC doesn't quite work. Anyway, this is the glossary. 3 greater than signs, or 3 right-pointing chevrons in a row, is the default Python prompt of the interactive shell, often seen for code examples which can be executed interactively in the interpreter. And 3 dots can be the secondary prompt, the default Python prompt of the interactive shell when entering the code for an indented code block, when within a pair of matching left and right delimiters, such as parentheses, square brackets, curly braces, or triple quotes, or after specifying a decorator. Or it can just be ellipses dots, the ellipses built-in constant. 2 to 3, that is the numeral 2, the letter T, the letter O, and the numeral 3, a tool that tries to convert Python 2.x code to Python 3.x code by handling most of the incompatibilities which can be detected by parsing the source and traversing the parse tree. 2 to 3 is available in the standard library as lib2 to 3. A standalone entry point is provided as tools/scripts/2 to 3. See 2 to 3, automated Python 2 to 3, code translation. Abstract base class. Abstract base classes complement duck typing by providing a way to define interfaces when other techniques like hasAttribute would be clumsy or subtly wrong. Story of my life. For example, with magic methods, ABCs introduce virtual subclasses, which are classes that don't inherit from a class but are still recognized by isInstance and isSubclass. See the ABC module documentation. Python comes with many built-in ABCs for data structures in the collections.abc module, numbers in the numbers module, streams in the IO module, import finders and loaders in the importlib.abc module. You can create your own ABCs with the ABC module. Annotation. Annotation is a label associated with a variable, a class attribute, or a function parameter or a return value, used by convention as a type hint. Annotations of local variables cannot be accessed at runtime, but annotations of global variables, class attributes, and functions are stored in the dunder annotations, that is __annotations __, special attribute of modules, classes, and functions, respectively. See variable annotation, function annotation, PEP 484 and PEP 526, which describe this functionality. Also see annotations best practices for best practices when working with annotations. Argument. A value passed to a function or method when calling the function. There are 2 kinds of argument. A keyword argument is an argument preceded by an identifier, for instance, name, =, in a function call, or passed as a value in a dictionary preceded by ***. For example, 3 and 5 are both keyword arguments in the following calls to complex function here. So, because we've got the keyword equaling, and that it sets your argument equal specifically to a specified parameter, real, same with image. And here, we've done the same thing by passing it as a value in a dictionary preceded by ***, which assigns, will map this to this and this to this in the same way that these values are assigned to the things that the equal signs are, assigning them to. Positional argument is an argument that is not a keyword argument. That's how they define it in this. Positional arguments can appear at the beginning of an argument list and or be passed as elements of an iterable preceded by *. For example, 3 and 5 are both positional arguments in the following calls, just like above. But in this case, these arguments will only be associated with the parameters defined in the function definition by being written in the same order, the same position that those parameters were written. And so if you put 5 here and 3 here, you'd get a reverse, and that would change what those arguments were being passed into. Whereas in this, you could reverse the order of these, and because you've set them explicitly equal to specific parameters, the order won't matter anymore. So that's why it's not positional anymore. Arguments are assigned to the named local variables in a function body. See the calls section for the rules governing this assignment. Syntactically, any expression can be used to represent an argument. The evaluated value is assigned to the local variable. See also the parameter glossary entry, the FAQ question on the difference between arguments and parameters in PEP 362. Asynchronous context manager. An object which controls the environment seen in an async with statement by defining __, a enter __, and the dunder a exit methods. Introduced by PEP 492. If you've missed this fact, a dunder is double underscore. That's why I'm saying these are, you could call these dunders instead of just reading out __ each time. Asynchronous generator. A function which returns an asynchronous generator iterator. It looks like a coroutine function defined with async def, except that it contains yield expressions for producing a series of values usable in an async for loop. Usually refers to an asynchronous generator function, but may refer to an asynchronous generator iterator in some contexts. In cases where the intended meaning isn't clear, using the full term avoids ambiguity. An asynchronous generator function may contain await expressions as well as async for and async with statements. Asynchronous generator iterator. An object created by an asynchronous generator function. This is an asynchronous iterator, which when called using the dunder a next method returns an awaitable object which will execute the body of the asynchronous generator function until the next yield expression. Each yield temporarily suspends processing, remembering the location execution state, including local variables and pending try statements. When the asynchronous generator iterator effectively resumes with another awaitable returned by the dunder a next, it picks up where it left off. See PEP 492 and PEP 525. Asynchronous iterable is an object that can be used in an async for statement. Must return an asynchronous iterator from its __, a iter __, method. Introduced by PEP 492. Asynchronous iterator is an object that implements the dunder a iter and the dunder a next methods. Dunder a next must return an awaitable object. Async for resolves the awaitables returned by an asynchronous iterator's a next method until it raises a stop async iteration exception. Introduced by PEP 492. Attribute. A value associated with an object which is usually referenced by name using dotted expressions. For example, if an object O has an attribute A, it would be referenced as O.A. It is possible to give an object an attribute whose name is not an identifier as defined by identifiers and keywords, for example using setAttribute, if the object allows it. Such an attribute will not be accessible using a dotted expression and would instead need to be retrieved with getAttribute. Awaitable. An object that can be used in an await expression. It can be a coroutine or an object with a dunder await method. See also PEP 492. BDFL, Benevolent Dictator for Life, aka Guido van Rossum, Python's creator. That wasn't the best pronunciation, but it's not like Guido, it's like Guido something. Binary file. A file object able to read and write bytes-like objects. Examples of binary files are files opened in binary mode, such as an RB, WB, read binary, write binary, or RB+, which I don't remember the meaning of. sys.stdin.buffer, standard input, sys.stdout, standard output, .buffer, and instances of io.bytesio and gzip.gzip file. See also text file for a file object able to read and write string objects. Borrowed reference. In Python's C API, a borrowed reference is a reference to an object where the code using the object does not own the reference. It becomes a dangling pointer if the object is destroyed. For example, a garbage collection can remove the last strong reference to the object and so destroy it. Calling pi_all caps incref, INCREF, on the borrowed reference is recommended to convert it to a strong reference in place, except when the object cannot be destroyed before the last usage of the borrowed reference. The pi_new_ref function can be used to create a new strong reference. Bytes-like object. An object that supports the buffer protocol and can export a C-contiguous buffer. This includes all bytes, byte array, and array.array objects, as well as many common memory view objects. Bytes-like objects can be used for various operations that work with binary data. These include compression, saving to a binary file, and sending over a socket. Some operations need the binary data to be mutable. The documentation often refers to these as read-write bytes-like objects. Very rhythmic name. Example mutable buffer objects include byte array and a memory view of a byte array. Other operations require the binary data to be stored in immutable objects, read-only bytes-like objects. Examples of these include bytes and a memory view of a bytes object. Bytecode. Python source code is compiled into bytecode, the internal representation of a Python program in the C Python interpreter. The bytecode is also cached in .pyc files so that executing the same file is faster the second time. Recompilation from source to bytecode can be avoided. This intermediate language is said to run on a virtual machine that executes the machine code corresponding to each bytecode. Do note that bytecodes are not expected to work between different Python virtual machines, nor to be stable between Python releases. A list of bytecode instructions can be found in the documentation for the dis module. Callable. A callable is an object that can be called, possibly with a set of arguments. See argument. With the following syntax. The callable, the arguments. A function, and by extension a method, is a callable. An instance of a class that implements the callDunder method is also a callable. Callback. A subroutine function which is passed as an argument to be executed at some point in the future. Class. A template for creating user-defined objects. Class definitions normally contain method definitions which operate on all instances of the class. Class variable. A variable defined in a class and intended to be modified only at class level, i.e. not in an instance of the class. Complex number. An extension of the familiar real number system in which all numbers are expressed as a sum of a real part and an imaginary part. Imaginary numbers are real multiples of the imaginary unit, the square root of -1, often written I in mathematics or J in engineering. Python has built-in support for complex numbers, which are written with this latter notation. The imaginary part is written with a j suffix, e.g. 3 plus 1j. As a multiple of that imaginary unit is j times 1j. To get access to complex equivalents of the math module, use CMath. Use of complex numbers is a fairly advanced mathematical feature. If you're not aware of a need for them, it's almost certain you can safely ignore them. Word to your mother. Context manager. An object which controls the environment seen in a with statement by defining the dunder enter and the dunder exit methods. See PEP 343. Context variable. A variable which can have different values depending on its context. This is similar to thread local storage, in which each execution thread may have a different value for a variable. However, with context variables, there may be several contexts in one execution thread, and the main usage for context variables is to keep track of variables in concurrent asynchronous tasks. See context vars. Contiguous. A buffer is considered contiguous exactly if it is either C-contiguous or Fortran contiguous. Zero-dimensional buffers are C and Fortran contiguous. In one-dimensional arrays, the items must be laid out in memory next to each other in order of increasing indices starting from 0. In multidimensional C-contiguous arrays, the last index varies the fastest when visiting items in order of memory address. However, in Fortran contiguous arrays, the first index varies the fastest. Delightful. Coroutines are a more generalized form of subroutines. Subroutines are entered at one point and exited at another. Coroutines can be entered, exited, and resumed at many different points. They can be implemented with the async def statement. See also PEP 492. Coroutine function. A function which returns a coroutine object. A coroutine function may be defined with the async def statement and may contain await, async for, and async with keywords. These were introduced by PEP 492. C Python. The canonical implementation of the Python programming language as distributed on python.org. The term CPython is used when necessary to distinguish this implementation from others, such as Jython, written in Java, or IronPython, which I can't remember what that was written in. Decorator. A function returning another function, usually applied as a function transformation using the wrapper syntax with that @ sign as sort of affixed to the top of a function. Common examples for decorators are class method and static method. The decorator syntax is merely syntactic sugar. The following two function definitions are semantically equivalent. So say we've got the function f takes one arg within its definition. We set, wait, no, that's not part of its definition, that's afterward. Oh yeah, that we can set that function equal to static method with that function passed in as argument, or we can just use static method as a wrapper, decorate it like a bow on top of the function definition. The same concept exists for classes, but is less commonly used there. See the documentation for function definitions and class definitions for more about decorators. Descriptor. Any object which defines the methods $get, $set, or $delete. When a class attribute is a descriptor, its special binding behavior is triggered upon attribute lookup. Normally, using a.b to get, set, or delete an attribute looks up the object name b in the class dictionary for a. But if b is a descriptor, the respective descriptor method gets called. Understanding descriptors is a key to a deep understanding of Python because they are the basis for many features, including functions, methods, properties, class methods, static methods, and reference to superclasses. For more information about descriptors methods, see Implementing Descriptors or the Descriptor How-To Guide. Dictionary. An associative array. An associative array. It's a very descriptive name, actually, where arbitrary keys are mapped to values. The keys can be any object with the #hash and $eq methods, called a hash in Perl. Dictionary comprehension. A compact way to process all or part of the elements in an iterable and return a dictionary with the results. For instance, say we made a variable results, and we set it equal to all its nonsense inside curly braces. This actually generates a dictionary containing key in mapped to a value in squared. And it does that for in range. It'll do that 10 times from 0 through 9. It will apply or connect those things, right? See displays for list sets and dictionaries. Dictionary view. The objects returned from dict.keys, dict.values, and dict.items are called dictionary views. They provide a dynamic view on the dictionary's entries, which means that when the dictionary changes, the view reflects these changes. To force the dictionary view to become a full list, use list with dictView, the list function with dictView passed in as argument. See dictionary view objects. Docstring. A string literal which appears as the first expression in a class, function, or module. While ignored when the suite is executed, the suite being like the body of code there, it is recognized by the compiler and put into the the dunder doc attribute of the enclosing class, function, or module, which you can then look up, so you can call that and just look at the doc string associated with a class or function, whatever, and it'll serve as a quick explanation for what it does. Since it is available via introspection, it is the canonical place for documentation of the object. Duck typing. A programming style which does not look at an object's type to determine if it has the right interface. Instead, the method or attribute is simply called or used. If it looks like a duck and quacks like a duck, it must be a duck. By emphasizing interfaces rather than specific types, well-designed code improves its flexibility by allowing polymorphic substitution. Duck typing avoids tests using type or is instance. Note, however, that duck typing can be complemented with abstract base classes. Instead, it typically employs has-attribute tests or EAFP programming. And if you don't know what that means, here it is. Easier to ask for forgiveness than permission. This common Python coding style assumes the existence of valid keys or attributes and catches exceptions if the assumption proves false. This clean and fast style is characterized by the presence of many try and except statements. The technique contrasts with the LBYL style common to many other languages such as C. Expression. A piece of syntax which can be evaluated to some value. In other words, an expression is an accumulation of expression elements, like literals, names, attribute access, operators, or function calls, which all return a value. In contrast to many other languages, not all language constructs are expressions. There are also statements, which cannot be used as expressions, such as while. Assignments are also statements, not expressions. Extension module. A module written in C or C++ using Python's C API to interact with the core and with user code. F-string. String literals prefixed with F or F, lowercase or uppercase, are commonly called F-strings, which is short for formatted string literals. See also PEP 498. File object. An object exposing a file-oriented API with methods such as read or write to an underlying resource. Depending on the way it was created, a file object can mediate access to a real on-disk file or to another type of storage or communication device. For example, standard input-output, in-memory buffers, sockets, pipes, etc. File objects are also called file-like objects or streams. Why the hell would they also call them file-like objects? There are actually three categories of file objects: raw binary files, buffered binary files, and text files. Their interfaces are defined in the I/O module. The canonical way to create a file object is by using the open function. Next in the glossary, file-like object, a synonym for file object. Whatever you say. File system encoding and error handler. Sorry, that just really tickled me. A second. Okay, file system encoding and error handler. Encoding and error handler used by Python to decode bytes from the operating system and encode Unicode to the operating system. The file system encoding must guarantee to successfully decode all bytes below 128. If the file system encoding fails to provide this guarantee, API functions can raise Unicode error. The sys.getFileSystemEncoding and sys.getFileSystemEncodeErrors functions can be used to get the file system encoding and error handler. The file system encoding and error handler are configured at Python startup by the pyconfig_read function. See file system_encoding and file system_errors members of pyconfig. See also the locale encoding. Finder. An object that tries to find the loader for a module that is being imported. Since Python 3.3, there are two types of finder: meta path finders for use with sys.meta_path, and path entry finders for use with sys.path_hooks. See PEP 302, PEP 420 and PEP 451 for much more detail. Floor division. Mathematical division that rounds down to the nearest integer. The floor division operator is //. For example, the expression 11 // 4, or 11 floor divided by 4, evaluates to 2, in contrast to the 2.75 returned by float true division. It just gets rid of the remainder. It returns the remainder. Note that, wait a second. No, never mind. Yes, it rounds down to the nearest integer. I'm not sure what I was thinking. I'm thinking of modulo. Not floor division. Okay. Note that negative 11, clarify with a parenthetical statement, floor divided by 4, is negative 3, because that is negative 2.75 rounded downward. It will always round down. Function. A series of statements which returns some value to a caller. It can also be passed 0 or more arguments, which may be used in the execution of the body. See also parameter, method, and the function definitions section. Function annotation. An annotation of a function parameter or return value. Function annotations are usually used for type hints. For example, this function is expected to take 2 int arguments and is also expected to have an int return value, integer. You see, takes into returns a value. That is an integer. Function annotation syntax is explained in section function definitions. See variable annotation and PEP 484, which describe this functionality. Also see annotations best practices for best practices on working with annotations. So future is a future statement. So, say from the dunder future import a given feature directs the compiler to compile the current module using syntax or semantics that will become standard in a future release of Python. How would it, what? The dunder future module documents the possible values of feature. By importing this module and evaluating its variables, you can see when a new feature was first added to the language and when it will or did become the default. Okay, here we get an example about a feature, division feature or something? I'm fucking confused about that. Garbage collection. The process of freeing memory when it is not used anymore. I do the same thing. Python performs garbage collection via reference counting and a cyclic garbage collector that is able to detect and break reference cycles. The garbage collector can be controlled using the GC module. Generator, a function which returns a generator iterator. It looks like a normal function, except that it contains yield expressions for producing a series of values usable in a for loop that can be retrieved one at a time, generated at the time at which they are iterated through, with the next function. Well, it seems the AC is working again. Shit, where was it? Yield expression, yeah, right. Usually refers to a generator function, but may refer to a generator iterator in some contexts. In cases where the intended meaning isn't clear, using the full term avoids ambiguity. Generator iterator is an object created by a generator function. Each yield temporarily suspends processing, remembering the location execution state, including local variables and pending try statements. When the generator iterator resumes, it picks up where it left off, in contrast to functions which start fresh on every invocation. Generator expression is an expression that returns an iterator. It looks like a normal expression followed by a for clause defining a loop variable, range, and an optional if clause. The combined expression generates values for an enclosing function. So, for instance, we could get the sum of I times I, the thing, It's like this is the operation that you're going to apply for each step in this iterator, or this iterable, the range 10. So from 0 to 9, you will multiply each one of those numbers by themselves, and this will return the sum of the squares from 0 through 9, 285. Generic function. A function composed of multiple functions implementing the same operation for different types. Which implementation should be used during a call is determined by the dispatch algorithm. See also the single dispatch glossary entry, the functools.single dispatch decorator, and PEP 443. A generic type. A type that can be parameterized, typically a container class such as list or dict, used for type hints and annotations. For more details, see generic alias types, PEP 483, PEP 484, PEP 585, and the typing module. GIL. See Global Interpreter Lock. Global Interpreter Lock. Did that have to be its own thing in its own entry in the glossary? Whatever. The mechanism used by the CPython interpreter to assure that only one thread executes Python bytecode at a time. This simplifies the CPython implementation by making the object model, including critical built-in types such as dict, implicitly safe against concurrent access. Locking the entire interpreter makes it easier for the interpreter to be multi-threaded, at the expense of much of the parallelism afforded by multiprocessor machines. However, some extension modules, either standard or third-party, are designed so as to release the GIL when doing computationally intensive tasks such as compression or hashing. Also, the GIL is always released when doing I/O. Past efforts to create a free-threaded interpreter, one which locks shared data at a much finer granularity, have not been successful because performance suffered in the common single-processor case. It is believed that overcoming this performance issue would make the implementation much more complicated and therefore costlier to maintain. Hash-based PYC. A bytecode cache file that uses the hash rather than the last modified time of the corresponding source file to determine its validity. See cached bytecode invalidation. Hashable. An object is hashable if it has a hash value which never changes during its lifetime, and it would need a dunder hash method. And it can be compared to other objects, which can be compared to other objects, it needs the dunder EQ method. Hashable objects which compare equal must have the same hash value. Hashability makes an object usable as a dictionary key and a set member, because these data structures use the hash value internally. It just means that there's a fixed point and place in computer memory that it's attached to. So it can be used in places that need immutable things, like the keys of dictionaries. Most of Python's immutable built-in objects are hashable. Mutable containers, such as lists or dictionaries, are not. Immutable containers, such as tuples and frozen sets, are only hashable if all of their elements are hashable. Objects which are instances of user-defined classes are hashable by default. They all compare unequal except with themselves, and their hash value is derived from their ID. IDLE, or IDLE, an integrated development and learning environment for Python. IDLE is a basic editor and interpreter environment which ships with the standard distribution of Python. Immutable, an object with a fixed value. Immutable objects include numbers, strings, and tuples. Such an object cannot be altered. A new object has to be created if a different value has to be stored. They play an important role in places where a constant hash value is needed, for example, as a key in a dictionary. Import path. A list of locations or path entries that are searched by the path-based finder for modules to import. During import, this list of locations usually comes from sys.path, but for subpackages it may also come from the parent package's dunder path attribute. Importing. The process by which Python code in one module is made available to Python code in another module. Importer. an object that both finds and loads a module, both a finder and loader object. Interactive. Python has an interactive interpreter, which means you can enter statements and expressions at the interpreter prompt, immediately execute them, and see their results. Just launch Python with no arguments, possibly by selecting it from your computer's main menu. It is a very powerful way to test out new ideas or inspect modules and packages. Remember to use help X. Interpreted, which explains the interpreter. Python is an interpreted language as opposed to a compiled one, though the distinction can be blurry because of the presence of the bytecode compiler. This means that source files can be run directly without explicitly creating an executable which is then run. Interpreted languages typically have a shorter development debug cycle than compiled ones, though their programs generally also run more slowly. See also interactive. Interpreter shut down. When asked to shut down, the Python interpreter enters a special phase where it gradually releases all allocated resources, such as modules and various critical internal structures. It also makes several calls to the garbage collector. This can trigger the execution of code in user-defined destructors or weakref callbacks. Code executed during a shutdown phase can encounter various exceptions as the resources it relies on may not function anymore. Common examples are library modules or the warnings machinery. The main reason for interpreter shutdown is that the dunder main module, or the script being run, has finished executing. Iterable. An object capable of returning its members one at a time, iterating through it. Examples of iterables include all sequence types, such as list, string, and tuple, and some non-sequence types like dictionary, file objects, and objects of any classes you define with an iter dunder method or with a getItem dunder method that implements sequence semantics. Iterables can be used in a for loop and in many other places where a sequence is needed, such as with the zip function, the map function, etc. When an iterable object is passed as an argument to the built-in function iter, it returns an iterator for the object. This iterator is good for one pass over the set of values. When using iterables, it is usually not necessary to call iter or deal with iterator objects yourself. The for statement does that automatically for you, creating a temporary unnamed variable to hold the iterator for the duration of the loop. See also iterator, sequence, and generator. Iterator. An object representing a stream of data. Repeated calls to the iterator's next dunder method, or passing it to the built-in function next, return successive items in the stream. When no more data are available to stop a stop iteration exception is raised instead. At this point, the iterator object is exhausted, and any further calls to its next dunder method would just be rude. Let it sleep. Just raise stop iteration again. Iterators are required to have an iter dunder method that returns the iterator object itself, so every iterator is also iterable and may be used in most places where other iterables are accepted. One notable exception is code which attempts multiple iteration passes. A container object, such as a list, produces a fresh new iterator each time you pass it to the iter function, or use it in a for loop. Attempting this with an iterator will just return the same exhausted iterator object used in the previous iteration pass, making it appear like an empty container. It's dark. More information can be found in iterator types. CPython implementation details. CPython does not consistently apply the requirement that an iterator define the iter dunder. Key function. A key function or collation function is a callable that returns a value used for sorting or ordering. For example, locale.stringx from strxfrm is used to produce a sort key that is aware of locale-specific sort conventions. A number of tools in Python accept key functions to control how elements are ordered or grouped. They include min, max, sorted, list.sort, heapq.merge, heapq.insmallest, heapq.inlargest, and itertools.groupby. There are several ways to create a key function. For example, the string.lower method can serve as a key function for case-insensitive sorts. Alternatively, a key function can be built from a lambda or anonymous expression, such as lambda r colon, and then a tuple containing r at index 0 and r at index 2. Also, operator.attributeGetter, operator.itemGetter, and operator.methodCaller are three key function constructors. See the sorting how-to for examples of how to create and use key functions. Keyword argument, C argument. Lambda, an anonymous inline function consisting of a single expression, which is evaluated when the function is called. The syntax to create a lambda function is lambda, and in square brackets, the parameters, followed by colon, space, expression. It's called an anonymous function, I assume, because it's not given a name. You don't define a name, it's just you lambda and then define what it's supposed to do, and it does it. LBYL, finally, look before you leap. This coding style explicitly tests for preconditions before making calls or lookups. This style contrasts with the easier to ask for forgiveness and permission approach, and is characterized by the presence of many if statements. In a multi-threaded environment, the LBYL approach can risk introducing a race condition between the looking and the leaping. For example, the code if key in mapping return mapping at key can fail if another thread removes key from mapping after the test but before the lookup. This issue can be solved with locks or by using the EAFP approach. A list is a built-in Python sequence. Despite its name, it is more akin to an array in other languages than to a linked list, since access to its elements is O of 1. List comprehension. A compact way to process all or part of the elements in a sequence and return a list with the results. So say we created a variable result and set it equal to all of this inside square brackets, means that this will be carried out and the list generated by carrying this out will be automatically produced and set equal to the name result. This generates a list of strings containing even hex numbers, 0x ... in the range from 0 to 255. For x in range 256, create this was formatted this way. And do that if each step along the way, whenever you find one that is even, because it evaluates to 0 at modulo 2. The if clause is optional. If omitted, all elements in range 256 are processed, because this one checks specifically for it to meet this condition, but you don't have to put the if clause in there. Loader, an object that loads a module. It must define a method named load_module. A loader is typically returned by a finder. See PEP 302 for details and import lib.abc.loader for an abstract base class. Locale encoding. On Unix, it is the encoding of the lc_c type, all caps, locale. It can be set with locale.setLocale and parenthetically locale.lc_c type, new_locale. On Windows, it is the ANSI code page, ANSI code page. On Android and VxWorks, Python uses UTF-8 as the locale encoding, and locale.getEncoding can be used to get the locale encoding. See also the file system encoding and error handler. Magic method, an informal synonym for special method. Okay. Mapping, a container object that supports arbitrary key lookups and implements the methods specified in the collections.abc.mapping or collections.abc.mutableMapping abstract base classes. Examples include dict, collections.defaultDict, collections.orderDict, and collections.counter. MetaPathFinder, a finder returned by a search of sys.meta_path. Meta pathfinders are related to, but different from, path entry finders. See import lib.abc.metapathfinder for the methods that metapathfinders implement. Metaclass, the class of a class. Class definitions create a class name, a class dictionary, and a list of base classes. The meta class is responsible for taking those three arguments and creating the class. Most object-oriented programming languages provide a default implementation. What makes Python special is that it is possible to create custom meta classes. Most users never need this tool, but when the need arises, meta classes can provide powerful, elegant solutions. They have been used for logging attribute access, adding thread safety, tracking object creation, implementing singletons, and many other tasks. More information can be found in meta classes. Method: a function which is defined inside a class body. If called as an attribute of an instance of that class, the method will get the instance object as its first argument, which is why it's usually called self. See function and nested scope. Method resolution order. Method resolution order is the order in which base classes are searched for a member during lookup. See the Python 2.3 method resolution order for details of the algorithm used by the Python interpreter since the 2.3 release. Module is an object that serves as an organizational unit of Python code. Modules have a namespace containing arbitrary Python objects. Modules are loaded into Python by the process of importing. See also package. Module spec. Namespace containing the import-related information used to load a module. An instance of importlib.machinery.modulespec. MRO. See method resolution order. Mutable. Mutable objects can change their value, but keep their ID. See also immutable. Named tuple. I've got I need a hiccup. It's not coming. The term named tuple applies to any type or class that inherits from tuple, and whose indexable elements are also accessible using named attributes. The type or class may have other features as well. Several built-in types are named tuples, including the values returned by time.localtime and os.stat. Another example is sys.float_info. Indexed access, 1024. Floatinfo.max, named field access. And isInstance sys.float_info, is that a tuple? Yes. Some named tuples are built-in types, such as the above examples. Alternatively, a named tuple can be created from a regular class definition that inherits from tuple, and that defines named fields. Such a class can be written by hand, or it can be created by inheriting typing.namedTuple, or with the factory function collections.namedTuple. The latter techniques also add some extra methods that may not be found in handwritten or built-in named tuples. Namespace: the place where a variable is stored. Namespaces are implemented as dictionaries. There are the local, global, and built-in namespaces, as well as nested namespaces in objects, in methods. Namespaces support modularity by preventing naming conflicts. For instance, the functions builtins.open and os.open are distinguished by their namespaces. Namespaces also aid readability and maintainability by making it clear which module implements a function. For instance, writing random.seed or itertools.isSlice makes it clear that those functions are implemented by the random and itertools modules, respectively. Namespace package: a PEP420 package which serves only as a container for sub-packages. Namespace packages may have no physical representation, and specifically are not like a regular package because they have no init.py file. See also module. Nested scope: the ability to refer to a variable in an enclosing definition. For instance, a function defined inside another function can refer to variables in the outer function. Note that nested scopes by default work only for reference and not for assignment. Local variables both read and write in the innermost scope. Likewise, global variables read and write to the global namespace and not inside something else. The non-local allows writing to outer scope. So if you just write the non-local, that word, in front of the variable assignment, you'll make it a non-local variable. New style class. Old name for the flavor of classes now used for all class objects. Yeah, I guess it couldn't be new forever. In earlier Python versions, only new style classes could use Python's newer versatile features like the dunder slots, descriptors, properties, the dunder get attribute, class methods, and static methods. But it's not the case anymore, I guess. So, I mean, just forget that little fact. It's not necessary to learn. Object. Any data with state, attributes, or value, and defined behavior, methods. Attributes or values, state, and methods define behavior. Also, the ultimate base class of any new style class. Fuck me. My microphone. Package. A Python module which can contain submodules or recursively sub-packages. Technically, a package is a Python module with a path dunder attribute, remember, which defines state. See also regular package and namespace package. A parameter is a named entity in a function or method definition that specifies an argument, or in some cases arguments, that the function can accept. There are 5 kinds of parameter. Positional or keyword specifies an argument that can be passed either positionally or as a keyword argument. This is the default kind of parameter. For example, foo and bar in the following. This assigns a default value to bar of none, and foo is just open for whatever you pass in there. Positional only specifies an argument that can be supplied only by position. Positional only parameters can be defined by including a / character in the parameter list of the function definition after the one that you want to keep only positional. For example, pos only 1 and pos only 2 in the following function definition, because there's a / after these two, you can only pass in arguments positionally. You can't in the argument passed in that function call, if you say pos only equals whatever it is, that's not what you're trying to do. Okay. And this one after the / can be positional or keyword still. Keyword only specifies an argument that can be supplied only by keyword. Keyword only parameters can be defined by including a single var positional parameter or var star or asterisk in the parameter list of the function definition before them. For example, keyword only 1 and keyword only 2 in the following. Arg star keyword only 1, keyword only 2. So whenever you call the function, if you want to pass the argument that you're passing in to keyword only 1, for instance, you'll have to type out keyword underscore only 1 =, and then whatever you're passing in as argument to that parameter, because it's keyword only. Var positional specifies that an arbitrary sequence of positional arguments can be provided, in addition to any positional arguments already accepted by other parameters. Such a parameter can be defined by prepending the parameter name with star. For example, args in the following. In case you didn't know, prepending is the opposite of appending, so it's affixing something to the very beginning, is to prepend. Put the star or stars, not before, like in this case, where it's still separated by a comma, but actually prepended. Var keyword specifies that arbitrarily many keyword arguments can be provided, in addition to any keyword arguments already accepted by other parameters. Such a parameter can be defined by prepending the parameter name with star star. For example, quarks in the example above. Parameters can specify both optional and required arguments, as well as default values for some optional arguments. See also the argument glossary entry, the FAQ question on the difference between arguments and parameters, the inspect parameter class, the function definition section, and PEP 362. Path entry. Single location on the import path, which the path-based finder consults to find modules for importing. Path entry finder. A finder returned by a callable on sys.path_hooks, that is, a path entry hook, which knows how to locate modules given a path entry. See importlib.abc.pathentryfinder for the methods that path entry finders implement. Path entry hook, a callable on the sys.path_hooks list, which returns a path entry finder if it knows how to find modules on a specific path entry. Path-based finder, one of the default meta path finders which searches an import path for modules. Path-like object. A path-like object is an object that's very much like a path. It's an object representing a file system path. A path-like object is either a string or bytes object representing a path, or an object implementing the os.pathlike protocol. An object that supports the os.pathlike protocol can be converted to a string or bytes file system path by calling the os.fsPath function. os.fsDecode and os.fSencode can be used to guarantee a string or bytes result instead, respectively. Introduced by PEP 519. I don't actually have a microphone stand. I stuck this into an empty box of tissues, so I'm having to try and adjust it to be angled right. PEP. Finally, because I don't know what the hell that means either, I just keep saying it. Python Enhancement Proposal. Makes sense. A PEP is a design document providing information to the Python community, or describing a new feature for Python or its processes or environment. PEPs should provide a concise technical specification and a rationale for proposed features. PEPs are intended to be the primary mechanisms for proposing major new features, for collecting community input on an issue, and for documenting the design decisions that have gone into Python. The PEP author is responsible for building consensus within the community and documenting dissenting opinions. See PEP 1. Portion. A set of files in a single directory, possibly stored in a zip file, that contribute to a namespace package as defined in PEP 420. Positional argument. C argument. Provisional API. A provisional API is one which has been deliberately excluded from the standard library's backwards compatibility guarantees. While major changes to such interfaces are not expected, as long as they are marked provisional, backwards incompatible changes, up to and including removal of the interface, may occur if deemed necessary by core developers. Such changes will not be made gratuitously. They will occur only if serious fundamental flaws are uncovered that were missed prior to the inclusion of the API. Even for provisional APIs, backwards incompatible changes are seen as a solution of last resort. Every attempt will still be made to find a backwards compatible resolution to any identified problems. This process allows the standard library to continue to evolve over time, without locking in problematic design errors for extended periods of time. See PEP 411 for more details. Provisional package, see Provisional API, Python 3000, nickname for the Python 3.x release line. Coined long ago when the release of version 3 was something in the distant future. This is also abbreviated to Py3K. That's pretty cool sounding, Py3K. Pythonic. An idea or piece of code which closely follows the most common idioms of the Python language, rather than implementing code using concepts common to other languages. For example, a common idiom in Python is to loop over all elements of an iterable using a for statement. Many other languages don't have this type of construct, so people unfamiliar with Python sometimes use a numerical counter instead, where they will take an iterable or something and calculate the length of it by passing it into the length function, and then calculate the range of that, passing that into the range function in order to print food at I, when you could just literally say for piece or for anything for I in food, print piece, right? You don't have to convert it first. Qualified name. A dotted name showing the path from the module's global scope to a class, function, or method defined in that module, as defined in PEP 3155. For top-level functions and classes, the qualified name is the same as the object's name. So class C, class D, define meth, self, pass, that c.qualName, the dunder qual name, will return c, c.d.qualName will return c.d, and c.d.meth.qualName will return c.d.meth, path. When used to refer to modules, the fully qualified name means the entire dotted path to the module, including any parent packages. Exempli gratia email.mime.text. Import email.mime.text, for instance, and then email.mime.text __ name __. What's it going to give you? Email.mime.text. Reference count. The number of references to an object. When the reference count of an object drops to 0, it is deallocated. Some objects are immortal and have reference counts that are never modified, and therefore the objects are never deallocated. Reference counting is generally not visible to Python code, but it is a key element of the C Python implementation. Programmers can call the sys.getRefCount function to return the reference count for a particular object. Regular package. A traditional package such as a directory containing an dunderinit.py file. See also namespace package. Slots, __slots__. A declaration inside a class that saves memory by pre-declaring space for instance attributes and eliminating instance dictionaries. Though popular, the technique is somewhat tricky to get right and is best reserved for rare cases where there are large numbers of instances in a memory-critical application. A sequence is any iterable which supports efficient element access using integer indices via the dunder getItem special method and defines a dunder length method that returns the length of the sequence. Some built-in sequence types are list, string, tuple, and bytes. Note that dict also supports __getitem __, and __length __, but is considered a mapping rather than a sequence because the lookups use arbitrary, immutable keys rather than integers. The collections.abc.sequence abstract base class defines a much richer interface that goes beyond just the dunder getItem and the dunder length, adding count, index, the dunder contains, and the dunder reversed. Types that implement this expanded interface can be registered explicitly using register. For more documentation on sequence methods generally, see common sequence operations. Set comprehension. Just like list and dictionary comprehensions, this is a compact way to process all or part of the elements in an iterable and return a set with the results. Results equals, say, any variable we make could be set equal to this set comprehension. And note that a set comprehension it's got curly braces, but it's not a dictionary. C for C in abracadabra, if C not in ABC, so if the if the thing at each step of the iteration through abracadabra, if that thing is something which is not found in this string, then it will add to the set, and so because most of these letters are found in this string ABC, it only gets a couple, R and D, and now we've got this set, which looks just like a dictionary, except there's no colon separating key and value pairs, right? It's just individual items. C displays for lists, sets, and dictionaries. Single dispatch. A form of generic function dispatch where the implementation is chosen based on the type of a single argument. Slice. An object usually containing a portion of a sequence. A slice is created using the subscript notation, square brackets with colons between numbers when several are given, such as in variable underscore, a slice of this variable called variable underscore name, 1:3:5 inside square brackets. The bracket subscript notation uses slice objects internally. Special method. A method that is called implicitly by Python to execute a certain operation on a type, such as addition. Such methods have names starting and ending with double underscores. Special methods are documented in special method names. Statement. A statement is part of a suite, a block of code. A statement is either an expression or one of several constructs with a keyword, such as if, while, or for. Static type checker. An external tool that reads Python code and analyzes it, looking for issues such as incorrect types. See also type hints in the typing module. Strong reference. In Python's C API, a strong reference is a reference to an object which is owned by the code holding the reference. The strong reference is taken by calling pi_incref, all caps, when the reference is created and released by pi_decref, all caps, when the reference is deleted. The pi_newRef function in title case can be used to create a strong reference to an object. Usually the pi_decref function must be called on the strong reference before exiting the scope of the strong reference, to avoid leaking one reference. See also borrowed reference. Text encoding. A string in Python is a sequence of Unicode code points in range U+0000 to U+10FFFF. To store or transfer a string, it needs to be serialized as a sequence of bytes. Serializing a string into a sequence of bytes is known as encoding, and recreating the string from the sequence of bytes is known as decoding. There are a variety of different text serialization codecs which are collectively referred to as text encodings. Text file. A file object able to read and write string objects. Often, a text file actually accesses a byte-oriented data stream and handles the text encoding automatically. Examples of text files are files opened in text mode, R or W, sys.stdin, standard input, sys.stdout, standard output, and instances of io.string io. See also binary file for a file object able to read and write bytes like objects. Triple quoted string. A string which is bound by 3 instances of either a quotation mark or an apostrophe. That is just a single or double as long as it's 3 on each side, just like you define a string with a single one of either one of these, as long as it's the same on each side. While they don't provide any functionality not available with single quoted strings, they are useful for a number of reasons. They allow you to include unescaped single and double quotes within a string, and they can span multiple lines without the use of the continuation character. You can just hit enter and keep writing like you're in a text editor is normally, making them especially useful when writing doc strings. Type. The type of a Python object determines what kind of object it is. In other words, what type of object it is. Every object has a type. An object's type is accessible as its class dunder, I don't know how to, it's dunder class attribute, or can be retrieved with type, with the type function with object name passed in as argument. Type alias. A synonym for a type created by assigning the type to an identifier. Type aliases are useful for simplifying type hints. For example, say we got this remove gray shades function that we've defined, and in it we've got colors colon, which will set equal to, or not set equal to, but that will make an alias for this, right? Let's see the type tuple indentant. Is list tuple indentant? Oh, I see. Could be made more readable like this. We could just set color equal to tuple and then a list containing int types, and then define, when we define this function, when you say colors list, we can just put in what we made earlier because we assigned these types to a identifier, I guess. I might need to see typing and pep484, which apparently describe this functionality. Type hint. An annotation that specifies the expected type for a variable, a class attribute, or a function parameter or return value. Type hints are optional and are not enforced by Python, but they are useful to static type checkers. They can also aid IDEs with code completion and refactoring. Type hints of global variables, class attributes, and functions, but not local variables, can be accessed using typing.get_type_hints. See typing in PEP 484, which describe this functionality. Universal new lines. A manner of interpreting text streams in which all of the following are recognized as ending a line. The Unix end-of-line convention, that is the new line \character \n, which is called new line elsewhere, the Windows convention \r\n, and the old Macintosh convention \r. See PEP 278 and PEP 3116, as well as bytes.split lines for an additional use. Variable annotation. An annotation of a variable or a class attribute. When annotating a variable or a class attribute, assignment is optional. Say we got a class C, and field annotation. Okay, so yeah, you don't need to assign, it's no equal sign, you're just annotating it directly, this field, right? Variable annotations are usually used for type hints. For example, this variable is expected to take integer values. Count expects to take integer, colon 0. I don't know. Variable annotation syntax is explained in section Annotated Assignment Statements. See function annotation PEP 484 and PEP 526, which describe this functionality. Also see annotations best practices for best practices on working with annotations. Virtual environment. A cooperatively isolated runtime environment that allows Python users and applications to install and upgrade Python distribution packages without interfering with the behavior of other Python applications running on the same system. See also VNV. Virtual machine. A computer defined entirely in software. Python's virtual machine executes the bytecode emitted by the bytecode compiler. Finally, Zen of Python, listing of Python design principles and philosophies that are helpful in understanding and using the language. The listing can be found by typing import this at the interactive prompt. It's fun, you should do that. Just go and open up the interpreter or the thing and just type import this and press enter, and it's darling what it returns. You did it. Now you've read the glossary.